Hello guys, welcome to 5.5, Total Change and the Fundamental Theorem of Calculus. So today this is going to be a little more theoretical compared to what we have done in 5.3 and 5.4, which were based on a lot of applications. All right, but let's again take a look at, let's say we have a function and the derivative of a function. Now, we actually spent quite a good amount of time talking about how to take the derivative, which goes from, which will make f into f prime, right? That prime notation represents a derivative. Now, as all things in mathematics, all the operations, they have opposite operation. So the opposite operation of derivative to go from f prime back to f, this process is called integration, right? Or sometimes called the antiderivative, right? The opposite of derivative. Okay. Now we actually talked about given some functions, how do we find the derivative? But we actually didn't talk about the techniques of integration. But it's actually not that bad. You can think about it as the opposite process of taking a derivative. All right, so we're going to start by introducing the fundamental theorem of calculus, which goes like this. Okay, if f prime is continuous on the interval between a and b, then the definite integral of f prime of x going from a to b is the function f, which is before the derivative, f of b minus f of a. In words, the definite integral of derivative of a function gives the total change in the function, right? So let's do a quick example. All right, let's say we have f of x is x squared, right? And we know that f prime of x is 2x by the power, right? We bring down the 2 and then you subtract the power by 1. All right, so let's say I want to take the definite integral from 1 to 2 of 2x dx. Right, now the 2x here is the f prime, right? F prime of x. Now, by the fundamental theorem of calculus, we know that since this is f prime, then the definite integral of f prime going from 1 to 2 is the original function f of 2 minus f of 1, right? Which is going to be 2 squared minus 1 squared, right? F, the original function, is x squared. So that just gives us 4 minus 1, which is equal to 3. Okay. So this is the way to evaluate a definite integral by using the fundamental theorem of calculus. Now, as we know from the previous sections, we know that this definite integral actually represents the area under the curve of the graph of 2x, right? So let's graph 2x, right? So 1, 2, and then 2, 4. All right, and then we have this line right here. Now the definite integral actually represents the area under this line between x equal to 1 and 2, which we have a big trapezoid here, right? So with the height 2 and 4. Right, and we know the area of trapezoid is top plus bottom, so 2 plus 4 multiplied by height divided by 2. Right, so that'll be 4 plus 2 multiplied by height, which is 1, over 2. That is 6 over 2, which is 3. All right, so both definition of definite integral will matches, right? Meaning we can use the area under the function to define the definite integral, or we can use the fundamental theorem of calculus to evaluate the integral as well. All right, let's look at another example. If we are given the graph of f prime, right? So here, figure 5.72 shows f prime, the rate of change of the value f of x of an investment over a 5-month period. Okay, so keep in mind that this graph is f prime, not f. And the vertical axis represents the rate of change of value of investment. And horizontal axis is in terms of months. All right, let's look at part A. When is the value of the investment increasing in value and when is it decreasing? All right, so we know f prime, if f prime is positive, that means the original function f is increasing. Now, if f prime is negative, that means the original function is decreasing. Right? So from here, the graph we can see, since this graph is f prime, if it's below the x-axis, meaning if it's between 0 and 3, notice that here f prime is negative. Right? So for the first 3 months, 0 to 3, or a little bit over 3, but let's just say it's 3. Right? The value of investment is actually decreasing. Right? F is decreasing. And then it's starting after the 3rd month, between month 3 and month 5. This is when f prime starts to be positive, meaning the original function f is now increasing. Right? So maybe the first 3 months, the value of investment is decreasing, right? So you're losing money per se, and then when it starts to increase, then you're starting to earn a little money back. Okay, let's look at part B. Does the investment increase or decrease in the value during 5 months? So in this case, we actually want to find the total change of investment between 0 and 5. Right? So by the fundamental theorem of calculus, we actually want to figure out the sum of these two areas. Right? Meaning we want to find the integral between 0 to 5, right? We want to find the 5-month period of f prime of t dt. Right. Now, since we have no information about f prime, we cannot answer this question accurately, right? But we can say what this will look like, right? This will be the total change in value, right? And then you can check that using the unit, right? So the unit for this is equal to dollars per month, which is the unit for f prime, multiplied by the unit of t, which is month, right? Which is just in terms of dollar amount, right? So that dollar amount can be positive or negative, right? If it's positive, it means, well, we'd actually earn money from the investment. If it's negative, it means we lose some money from the investment. Okay. All right, and here we have the solution in writing. Feel free to pause the video if you want to take a look at it, but it's basically what we just talked about. All right, so here is a problem 15 from your textbook. We are going to approach this problem using the fundamental theorem of calculus, and we're going to see this in a very different way. All right, so we're given the graph of f prime, and we're also given the first function value, f of 0, which is equal to 2. And we can see that in the table here. And our goal is to fill out all the empty boxes here. All right, so let's start with 1. Right? How do we start? Right? The idea is we're going to look at these two values, right, between 0 and 1. So what we're going to do is, since the only information we have is about f prime, right? So I'm going to integrate f prime from 0 to 1 dx. Now, I know from fundamental theorem of calculus, if I take the integral of f prime from 0 to 1, then this is actually equal to f of 1 minus f of 0, right? Let's go back a little bit and look at the fundamental theorem of calculus. Right? Integral of f prime is equal to f of b minus f of a, right? F of the upper bound minus f of the lower bound. Now, in our case here, our lower bound is 0 and our upper bound is 1, right? So we have f of 1 minus f of 0. So this is actually the one we want to find, right? And we know this already, right? It's given to us. And the question is, if this is our unknown, right? F of 1 is our unknown. And how do we proceed? Now we can actually find this. We can find this by looking at area under the curve. All right, so let's go up and look at the area between under the graph of f prime between 0 and 1. So we're looking at this triangle right here, right? This green triangle. Okay, so to find out the area of this green triangle, that is actually represented by the definite integral of f prime from 0 to 1 dx, right? Just like what we have here on the left-hand side of this equation. Right? And the area is just a triangle, right? So 1/2 base times height, right? Base is 1, height is 1, right? But it's the area is below the x-axis, so we have to make it negative. That's multiplied by a -1, right? And that will be -1/2. All right. So what we can do here is we can go back to our purple equation here and replace the definite integral on the left-hand side with -1/2. Right, so what we have from this equation is -1/2 is equal to f of 1, which is what we want to find, minus f of 0, which is known, that is equal to 2, right, from the table. Right, and to solve for f of 1, we just add the 2 over, and we get -1/2 plus 2 is equal to f of 1. That means f of 1 is equal to 3 over 2, right? 3 over 2. And done. And to find the next, right? To find f of 2, we can now do the integral from 1 to 2, right? Let's do one more, and then I want you guys to try the rest on your own. Okay. All right. So 1 to 2. Let's go ahead. So x 1 to 2. All right, so again, we're looking at the definite integral from 1 to 2 of f prime of x dx, which is f of 2 minus f of 1. And again, we already found f of 1 from part 1, right? Which is 3 over 2. And f of 2 is the unknown, is what we want to find, right? Unknown. And on the left-hand side, again, we have this definite integral, and we can find that using the area under curve. Under f prime for x between 1 and 2. Okay, and let's go up and look at the graph. So the area between 1 and 2, that's this rectangle right here. It's actually a square because you have 1 and 1 as the sides, right? So let's call that part 2. Okay, so part 2, the definite integral from 1 to 2 f prime of x dx is 1 times 1, right, which is a square, right? So, both sides have 1, and then since it's under the x-axis, multiplied by a negative to make it a negative value, right? So -1 is the value for the definite integral. Right, so we can say that, okay, the left-hand side, the definite integral is -1, which is equal to f of 2 minus 3 over 2. Therefore, f of 2 is equal to -1 plus 3 over 2, which is +1/2. Okay, and let's go back and fill in 1/2 here. Okay, so go ahead and take a few minutes. Feel free to pause the video. See if you can figure out the function value for 3, 4, 5, and 6. Okay. All right, so hopefully you guys had some time to try this one out. So basically what you need to do is you want to take the previous function value, right? Let's say I want to find f of 3, right? You take this value, right, 1/2, and add the area under the curve between 2 and 3. So between 2 and 3, this area is -1, right? So you add -1 to 1/2, you get negative. You add -1 to 1/2, and you get the next one, which is -1/2. And to get the next one, you take -1/2 and add the area between 3 and 4, which is this triangle right here has area -1/2. All right, so -1/2 plus -1/2 gives you 1. And by doing the same thing, you'll be able to get f of 5 and f of 6. Okay, so the area under the curve represents the change between any given x value. Okay, so you just need to add the area to the previous value to get whatever the next value is. All right, last thing from this section, we have a quick application using the fundamental theorem of calculus, which is marginal cost and change in total cost. So this is actually more applicable if you're in economics or a business major. But to put things in simple words, I want to talk a little bit about marginal cost. It's the amount of cost to produce one more product. Right. So a quick example, right? Let's say you want to make one iPhone, right? 12. Let's say it takes $500 to make one iPhone. Right? Cost. Now, if you make two iPhones, let's say it costs $700, right? So to produce one extra iPhone, that is a plus 200 cost. An extra $200 to produce a new iPhone, right? Then this is what's called the marginal cost. Okay. Now, of course, 3 iPhones might be a little different, maybe 3 for $800, right? So the marginal cost will be different. Right. But we're not going to get into too much details about the theory and the property of marginal cost, but I just want to bring that up. So let's see. If C prime of Q is a marginal cost function and C of 0 is a fixed cost, right? So fixed cost, you can think about it as buying a machine that puts all the parts together, right? That's something like a fixed cost. And cost to increase production from A units to B units is cost of B minus cost of A, right? So in this case, 700 will be the cost of 2 iPhones, and 500 will be the cost of 1 iPhone, right? C of 2 minus C of 1 is 700 minus 500, which is 200, right? And that's your marginal cost, right? And which can be found by taking the derivative from 1 to 2 of C prime of Q dQ. Okay. All right, total variable cost for B is 0 to B, right? You want to cover all the cost possible from between all the marginal costs from 0 unit to B units. And total cost for producing B units is the fixed cost plus the total variable cost, right? So right here in the last part, you have to include the fixed cost as part of your cost, right? The amount of money you spend buying machines, and then of course the amount you spend on buying materials, right? The amount of materials is going to affect how many products, how many units you make, right? And that will be the variable cost. Let's say like when you're making a hamburger, right? The grill would be a fixed cost, right? Because you just need one grill. Well, I guess you might need more, but let's say you are a small burger joint and you have a grill, and that's a fixed cost, right? Let's say it's $100. Right? Don't know if you can get a grill that cheap, but anyway, right? And that's a fixed cost, right? And that's it. You have to buy patties and buns, ketchups, tomatoes, mustard, right? Anything any of the things that you eat, right? So let's write it out: patties, buns, lettuce. Right, talking about this example is actually making me hungry. Tomatoes, right, and so on, right? The more you buy, the more burger you can produce, right? And these are your variable cost, right? And the variable cost can be calculated by taking the integral 0 to b c part of q dq. Right? And c prime of q, again, is your marginal cost. Right? Marginal cost. Okay. All right, so let's take a look at an example involving marginal cost. Right, so the blue line, that's our marginal cost, C prime, and it's asking us if the fixed cost is $1,000, estimated total cost of producing 250 items. All right, so since this blue curve is C prime, to find the actual cost, we are actually looking for the area under the curve, right? Which will be C of 250 minus C of 0, right? Which gives us the total variable cost, right? And also this area is represented by the definite integral from 0 to 250 C prime of Q dQ, okay? Which represents the total variable cost from earlier here. Okay, so basically, if we can find the area under the curve, then we'll be fine. All right, so first, we know that total cost is equal to fixed cost plus variable cost. Now we know that fixed cost is $1,000, right? And the variable cost is this, right? The definite integral of C prime of Q from 0 to 250, right? And all we need to do is figure out what this integral is, right? So total variable cost is equal to the definite integral of C prime of Q from 0 to 250. And the area under the curve is about 20 grid boxes, right? So we can, each grid box is 2 times 50, right? So this is 1 box, right? And we have about 20 of them, right? So multiply by 20, and that gives you something around 2,000, right? About 2,000. Okay, so $2,000 is the variable cost, right? So we can say that total cost is equal to 1,000 fixed cost from and then plus 2,000 variable cost, which is about $3,000. Okay, and that's it. So 5.5. The fundamental theorem of calculus, right? This equation is very useful, so keep that in mind. And also we can elaborate or explain this definite integral in different ways, right? Either using the fundamental theorem of calculus, like what we have here on the left-hand side, or by defining it as the area under the curve, okay? All right, thank you guys very much, and I'll see you next time.